Hey, what's up, everybody? I got a pretty good book for you today. It's What is Life by Paul Nurse. Paul Nurse is a Nobel Prize winning geneticist and fellow of the Royal Society. His list of accolades is longer than this video. You know, some of my favorite kinds of people are these brilliant scientists who make the effort of writing these books for the general public. Have you ever stopped to reflect on how amazing that is that we have such easy access to information like this? For most of human history, we've been totally ignorant on most things, and we can simply just place an order or look up any subject we are interested in. Someday I'll have to make a video about that. Anyway, about the book, Paul gives us a look at 5 topics in biology: the cell, the gene, natural selection, life as chemistry, and life as information. All super fascinating topics. One chapter for each. And then there's 2 chapters after those. The 6th chapter is Changing the World, using the information discussed for good. And the final chapter is What is Life? Each chapter subject is cleverly worked in as part of the next chapter, starting with the cell, and the cell in relation to the gene in relation to natural selection, etc. Chapter 1, the cell, Paul provides a very cursory introduction to the cell. He doesn't go into very much detail here. I was surprised at how short this section was, actually. He, covered, he covers how life is constructed from cells, the discovery of cells, cell division, and cancer. But yeah, he doesn't go into very much detail. In Chapter 2, the gene, he talks about the work of Gregor Mendel. He was the monk who did extensive breeding experiments with pea plants and made many important discoveries on heredity. He's considered the father of genetics. You have to love Gregor Mendel for his rigorous, meticulous, and thorough conduct in the ways of science. He truly was a shining example of how to do science, as they say, how to separate the wheat from the chaff. We get a little more history about the discoveries in the field of genetics, and on to evolution by natural selection for chapter 3. You get a nice introduction to natural selection and how it works. And of course, you can't talk about evolution by natural selection without talking about the work of Charles Darwin. And they do mention Alfred Russel Wallace as well. He mentions the 3 requirements for an organism to be shaped by natural selection, which are the ability to replicate, to have genetic heredity, and to have genetic variability. Of course, we've known for a long time about artificial selection and how that can produce desirable traits, but Darwin was the first one to present the case for a natural explanation, arguably the most beautiful work of science ever. He's widely regarded as the most important biology scientist in history. Paul mentions that all life forms share a common ancestor in the family tree, which is such a fascinating thing to read about. This book doesn't really go into too much detail, though. Here's a quote from Paul. To me, this is one of the biggest arguments for why humanity should care about the entire biosphere. All the different life forms that share our planet are our relatives. And this is true. This is the current understanding in science and biology. The next chapter is Life as Chemistry. You get a little history and information on chemistry, enzymes, polymers, and metabolism in living organisms. Paul talks about this idea, which is critical to life, which is compartmentation, which is kind of how a system can contain all these separate complex zones of chemical reaction without just becoming a big mixed up mess. Some of the concepts in this chapter confused me, like the description of making and the functions of ATP, which is the body's fuel that it needs to do work. I don't really have, out of all the chapters in this book, this is the one I was the least, chemistry is the one I'm the least familiar with. A part I did understand, which he stated beautifully, is how science, over a lot of time and work, has enabled us to understand that these complex systems can be understood in terms of chemistry and physics. For most of human existence, this wasn't the case. It's really a remarkable thing to consider. The next chapter is life as information. He talks about how in nature we see positive and negative feedback loops that manage homeostasis, like body temperature, blood sugar, and fluid volume. The example of a positive feedback loop he gives is when an apple begins to ripe, it emits ethylene, the presence of which catalyzes more ripening, which releases more ethylene. This is a really good example of a positive feedback loop, and I'm glad that he put that in there because positive and negative feedback loops are concepts that I've heard people confuse with the other meanings for positive and negative. The example he gives for negative feedback loop is one I've seen referenced in many books, and that is the centrifugal steam governor. The idea is that you have a steam-powered rotating motor with a weight on either side. As the power increases, centrifugal force from the spinning causes the weights to swing out, which opens valves, thereby decreasing the speed of the spinning, which lowers the weights back. This way you can govern how much output you generate with your machine. A beautiful example of negative feedback loop, a self-correcting system. He talks a lot about how these different components within a system have to be able to somehow communicate or to move information between them in order to work. He calls these parts modules. And later in the book, he says, and I'm paraphrasing here, in a way that parallels what we have seen in physics with the discovery of relativity and quantum mechanics, it could be that the complexity of biology will lead to strange and non-intuitive explanations, and to work these out, biologists will need ever more assistance from scientists in other disciplines, such as mathematicians, computer scientists, physicists, and even philosophers who are more used to thinking abstractly. That sounds like a direct parallel to his earlier statement about the communication and information exchange between different modules in a system being of central importance. If that was an intentional literary device, then that was masterful. It was a wow moment for me. And it reminded me of my old environmental science teacher. She said essentially the same thing with regard to science in general, how multidisciplinary approach is the way of the future. Now, assuming that parallel was intended, this is such a great example of writing that makes you think. And there's a lot of that in this book. So the next chapter is Changing the World. In this section, Paul briefly makes a case for better and applied science in medical and agricultural arenas. He talks a little bit about anti-vaxxers, people undermining herd immunity, the misuse of antibiotics, prospects with gene editing, ways to make more out of the farmable land that we have, engineering plants that could photosynthesize more efficiently, or thrive in drier climates. He mentions how a lot of people were against GMO due to misinformation, but he did leave out their biggest gripe, which, as I understand it, is engineering plants that can tolerate more pesticides. People didn't want that because they didn't want to increase their exposure to pesticides. So I'm a little surprised that he didn't mention that, but I do want to share a quote in regard to science and politics. He says, "The time for politics is after the science, not before. The world has seen too often how things go horribly wrong when the reverse is true." So to wrap up the book, he kind of summarizes the last chapter as what is life. In this section, he talks about all of the previous sections and he uses them to discuss the question, what is life? He goes on to say that on Earth, life is based of carbon polymers, but that we should not think that that's the only possible configuration for life in the universe. He asks the question, which came first, DNA, proteins, or cell membranes? Because if you take any of the three out, the system doesn't work. This is sort of a play on the irreducible complexity argument of creationists, and it's a good question. He discusses some of the ideas on that, some of today's thoughts on that, which is a way of saying I don't know, or we don't know, which to me, that's one of the greatest things about science. It is not knowing that drives our progress. Everything we know started out as something we didn't know. I think this is important to consider before we start throwing out ideas of supernatural forces. For in each and every case of our understanding, not once has a supernatural explanation turned out to be confirmed. Not once. And for each and every case, a natural explanation did. So one thing is clear, that is that almost all life in some way is dependent on other living things, as Earth is one vast, deeply connected ecosystem. And I really enjoyed this book. Whether you know nothing about these topics or have spent time studying them, I think anyone can get something out of this book. It's pretty brief. I read it in one day. This book, I would call it an appetizer. It's a bit of a teaser. I do have to say that almost everything in this book I've seen in a Richard Dawkins book before. This book made me want to read Dawkins, but for what the book is, it is a wonderful piece of work for sure. Good science writing engages you to think and reflect on the wonder of the natural world, and that's what this book did. Well, hey, thank you for watching this video. I know it was longer than usual, but I hope you enjoyed it. And if you have any interest in biology, are curious about what we are and how we do it, or if you're curious about life in general, go pick up What is Life by Paul Nurse.